Okay, what I want to provide you today is an example of solving linear systems through combination. Here's the situation I was talking about the other day, is not all the time are the x's and y's going to be by themselves, meaning coefficient of 1 or negative 1. Oftentimes we have applications here where we have coefficients to the variable that are greater than 1, such as this, and less than negative 1, such as this. There's nothing here that we don't want to use substitution on this because we'll end up with some ugly fractions. So what combination allows us to do is to solve particular problems like this. Now, the neat thing about solving through combinations is the first step you have to do is make sure you're in standard form. X plus y is equal to the constant. Now, what you also have to do is notice that I've got everything lined up here. In both these equations, as examples I'm giving you today, they're lined up. I've got the x's here, I've got the y's right here, and I've got the constants right here. And what we're allowed to do through combination is to basically add up those two equations, add them up together. Now, watch what happens. When I come down this column and I go negative 3x plus 3x, well, that's 0. We knock it out. We go on over here to the y's. We got negative 4y plus 3 is a negative y. And we add up 2 minus 3 and we get negative 1. So the solution to y is equal to positive 1. So we got ordered pair. We're able to put in a 1 right there for half of it for the y value. Now, since I know what my y value is, I simply plug it into one of these two equations. So I'll plug it into the bottom. I got 3x plus 3 times y, which is 1, so I got 3 times 1 is 3, is equal to negative 3. I now solve the equation. Take a negative 3 to both sides. Get 3x is equal to negative 6. And so I divide both sides by 3, and my x is now negative 2. So now I can complete my ordered pair, and the solution to those two equations are negative 2 and 1. Now, go to the second example. It's a little more complex. You notice that I look at my numbers here, and nothing cancels out like it did right here on the first step. And you may think, oh, I can't really do anything with this. Well, yes, you can. Through the use of distributive property, you're able to change all of these coefficients, if needed, in order for them to cancel out. And the clue to look for are the first two numbers, and it doesn't matter if you use the x coefficients or the y coefficients, it doesn't matter. But notice if I use the opposite number here, and I don't mean opposite by changing the sign, but if I got a 2 here and a 7, well, if I multiply up here by the 7 and down here by the 2, look what happens to these two numbers. I get 14. 7 times 2, 14, and 2 times 7 is going to be 14. The tricky part you got to notice here is I've got negative signs. And so I would end up with negative 14x and another negative 14x, which when I add together we'll get negative 28, and that won't help me. But if I change one of these factors to a negative, let's find out what happens. Now remember, we're using distributive property, so everything in here in this case gets multiplied by negative 7. So we've got to start off, we got negative 7 times negative 2x is a positive 14x minus 42y is equal to negative 42. This other line here, now we've got a negative 14x. Now look what happens. They're going to be canceling out here pretty soon. Plus 16y is equal to negative 10. So now I can add them up. What happens? That's going to go away because that equals 0. Here I've got a negative 26y is equal to negative 52. Well, divide both sides out by negative 26. And y will equal a positive 2. So, ordered pair up here, I know what my y value is 2. Now, since you know what y is, I've got 4 choices to plug back in. I'm going to plug in, it's got lower numbers here, so I'm going to use this top equation and plug in the value for y equals 2 right in here. So, I got negative 2x plus 6 times 2, I'll show you this step, is equal to 6. So I come through here, negative 2x plus 12 is equal to 6. I then subtract 12 from both sides. I know you know how to do this already. So I got negative 2x is equal to negative 6. Divide both sides by negative 2. Lo and behold, I know what my solution for x is now. It is a positive 3. So my solution to this system of equation is 3, 2.